Hello everyone, I'm Giancarlo Guizzardi and I'm presenting today this paper entitled Building Correct Taxonomies with a Well-Founded Craft Grammar. This is work done with Jefferson Batista, João Paulo Almeida, and Eduardo Zambon from the Federal University of Espírito Santo in Brazil, and I'm affiliated to the Free University of Bolzano in Italy and the University of Twente in the Netherlands. This is a taxonomy. Taxonomy connecting different types of rocks. We have here rock, which can be specialized in sedimentary rock, which can be specialized in gray sedimentary rock. We have gray rock, large rock, and bed metamorphic rock. Taxonomies connect types via subtyping relations. For example, sedimentary rock is a subtype of rock. However, we have the feeling that these types should not be put in the same logical footing. Being a sedimentary rock is not the same as being a gray rock or being a pet rock. Let's take another example. Here we have a person which is specialized in teenager, in man, which specialized in husband, person specialized legal party, and so does organization. A universe is a subtype of organization, and a client is a subtype of legal party. Again, we have the feeling that being a person is not the same as being a husband or not the same as being a teenager. And although individual people and organizations can be an instance of client, being a client as a person is not the same as being a person. Taxonomies are not only defined between entity types or object types. Here's a taxonomy of relationships or relation types. An agreement can be specialized in a conjugal relationship, which can be specialized in a legally recognized conjugal relationship, which can be specialized in a marriage or stable civil partnership. Again, being a civil partnership is different somehow from being a stable civil partnership. And being a marriage is different from being a marriage with partial separation of assets. In the sense that being a marriage seems to be much more stable and essential for a relationship, while being a marriage with partial separation of assets is something that can change about that relationship. Taxonomies are fundamental to many areas of computer science and also of information science, knowledge organization and information science. In computer science, they're fundamental to conceptual modeling, knowledge representation, software engineering, and so on. However, there are very few methodologies on how to build correct taxonomies. Notable examples are OntoClean, the OntoClean methodology, and the OntoUML language. Again, OntoClean is a methodology which evolved into what became the OntoUML language. OntoUML is a language that has many features which are not related to taxonomy relations, but its taxonomical part is an extension of OntoClean. And OntoClean and OntoUML put forth a number of modeling distinctions which are based on ontological meta properties. OntoClean, for example, has been used to evaluate and rectify many large structures like Psych and WordNet, for example. And OntoUML is a language that has been used in many practical case and practical applications, and that has its own ecosystem of tools. What is the idea behind a language like OntoUML? The idea is that it follows this principle of ontology-based language engineering, in which, given an ontology as an axiomatic representation of a domain conceptualization, I could engineer a modeling language such that this language would have modeling distinctions that would reflect the distinctions put forth by this ontology. And moreover, since this axiomatic theory delimits a set of admissible interpretations of that theory, ideally, this language will be as such that its grammar would only allow for the expression of models that represent those interpretations which are admissible according to this underlying theory. In other words, given an ontology of a domain, I can design a language that reflects the distinctions put forth by that ontology, and that language should select as grammatically valid models of that language only those whose interpretations are valid interpretations according to that axiomatic theory. And that's exactly what we do in this paper. We produce a modeling language for building correct taxonomies that has these properties, that provably has these properties. So a language for building taxonomies that reflect the ontological distinctions and axiomatization put forth by a particular ontological theory of types. And this theory of types explains that not all types are created the same. It doesn't put all types in the same logical footing. Let's go back to the first taxonomy that we saw. This taxonomy actually comes from a classical paper by Breckman, Fikes, and Levesque from 1985, in which they ask how many kinds of rock do we have here. In fact, they go on in saying that this is a very, very dangerous question because it's very hard to determine to have a determinate answer to this question because you can have any logical combinations of types producing more types. The problem here is that the authors take kind to be a synonym of type. In this theory, instead, we show that kind is just one type of type, albeit a very, very important one. Let's take an example. This individual here instantiates the type senior citizen, but he's identical to this individual that instantiates the type boy. How can they be identical if they are not even of the same type? They are also identical to these other individuals here. We have a singer and we have an actor, and they are all identical. So how can a singer be identical to an actor, which is identical to a boy that is identical to a senior citizen? We can even do counterfactual reasoning and imagine that this individual in a different world hadn't dropped out from the London School of Economics, and he's actually an economist now. Well, these identity relations can be established because there is one type that all these individuals, which are identical, instantiate and instantiate in all types of situations. One single kind that provides a principle of identity that establishes the identity of its instances in all possible situations, in all possible worlds. And this unique kind for this individual is the kind person. Mick Jagger is necessarily a person, the type that defines all the essential properties of Mick Jagger, but he's contingently a boy and a senior citizen, a change that is due to intrinsic change in Mick Jagger. He's also contingently a singer, an actor, and an economist, changes which are due to relational properties. He is able to instantiate these types by establishing or terminating certain relations with different entities. We can even say that Mick Jagger can be classified in kinds that he shares with things of other kinds. So Mick Jagger instantiates a type, a cultural heritage item, for example, that is instantiated by things of different kinds, for example, the Taj Mahal. So here, we can build a taxonomy, a typology of types. So this is a taxonomy at the meta level, right? So a taxonomy of meta types, in which we have that entity types can be sortals or non-sortals, and sortals are types which are either kinds or specialization of kinds. Kinds are rigid, so types that classify their instance in all possible situations, and kinds can be specialized into other rigid kinds, which are called subkinds. Under rigid sortals, types that dynamically classify their instance can be phases, which are related to the change in intrinsic properties, or rows, which are related to change in relational properties. Non-sortals are things which classify things of multiple kinds. They can be rigid, this is what is called a category, or non-rigid. For example, uh, phase mixins, which are abstractions over phases played by phases of different kinds, row mixins, which are abstractions of rows played by instances of different kinds, and mixins, which are types that necessarily classify instances of certain kinds but contingently classify instances of other kinds. If I could offer a geometric metaphor, it is like our universe here is tessellated in kind. So everything belongs to one kind and one unique kind and cannot migrate out of that kind. So these are rigid borders. Inside a kind, we can have other rigid borders which define subkinds. Phases and rows, these anti-rigid sortals, are like shadows moving, classifying and declassifying things within the borders of a kind. Take this, for example, the kind to be the kind person and this to be the kind teenager. As the world changes, you have a teenager classifying and declassifying different people. Mixins are types which cross these borders, which classify things of multiple kinds. They can be rigid or they can be these moving shadows, classifying things of multiple kinds. So coming back to Brackman, Fikes, and Levesque, we can easily answer that question now. How many kinds of rock do I have here? Well, we have three kinds of rock. We have igneous rock, sedimentary rock, and metamorphic rock. Being a gray sedimentary rock is a phase of a sedimentary rock. Being a large gray igneous rock is a phase of an igneous rock. And being a pet metamorphic rock is a role played by a metamorphic rock which establishes a pet relation with an owner. Again, if you look at this model, we have two kinds of things here, people and organization. People can be specialized in this conceptualization in two subkinds, man and woman, and organization in the subkind university. Husband and wife are roles of a man and woman, respectively. A teenager is a phase of a person, and a legal party is a category that classifies both people and organization rigidly. Both people and organization are necessarily here legal parties. A role mixing is a role played by things of the kind people and of the kind of organization. So it's a contingent, relationally related, relationally dependent mixing, non-sortal. Not only we have a taxonomy of types, but there are also rules on how these things can be combined, ontological rules that come from this theory. So we have, for example, a rule that says every entity should instantiate one unique kind, otherwise you would inherit an incompatible principle of identity and you have an ontological inconsistency. Non-sortals cannot specialize sortal because otherwise they would specialize the identity provided by the sortals and they would become a sortal. Rigid types cannot specialize anti-rigid types because it leads to a logical contradiction, and so on. These rules put together, they constrain how we can associate a given element of a given type with other elements. So we know, for example, that take roles. We know that all instances of a given role are of the same kind. For example, all students are people. All instances of a role instantiate that type contingently. No student is necessarily a student. Instance of a kind instantiate that role in a relational context. For example, in order for you to be a student, you have to be enrolled in an education institution, and roles cannot be supertype of a rigid type. As a result, what we get is a pattern constraining how these things can appear in the model. So every time you have a role in a model, this role will have to specialize a unique kind and it has to be established in the scope of a relation. So what happens is, because this language commits to an ontological theory, it's not ontologically neutral, the primitives of this language become patterns and not low granularity primitives like types and relations and attributes and so on. So what we did in this paper is to formalize this language for building taxonomic structures actually using a pattern grammar. So a graph grammar with a graph rewriting, graph transformation rules that captures the pattern of the underlying theory. In the paper, we also prove that this grammar is sound, so all taxonomies that you build with it are correct, and that it's complete. It builds all the possible taxonomies according to this ontology. And it does that in a way that it's independent of metamodel. So it can be used for OntoUML, but also for other languages like ORM or even for semantic web language by building plugins to tools like Protege and so on. That's it for today. I'm happy to take questions now.